Hello guys, this is George Bunjet with Murray State University, and today we'll present the distance measurements that we have in the measurements class. And as you can see, we'll use the file that we used previously for the LED measurements as an introduction for the class, and similar we use similar toolboxes and libraries because it's just a modify. We adjusted that file in order to measure a distance, and we have here a micrometer that tells us the real value of the distance in microns, and also we have this sliding potentiometer, and that the voltage, the potentiometer is just a resistor that is variable and is connected to the Arduino board, and we power it from 5 volts. It goes through this potentiometer to these resistors, and then as you can see, I put here a small resistor that is connected between one end of the potentiometer and the ground, and this is where I have connected my measurement, exactly like we had in the midpoint for the LED measurements. The file is very similar. The only toolbox that is new here is one that's called Wind Sound. It's because I'm using it to tell when I am about to move the potentiometer, the micrometer, to rotate it. And again, I am going to make a travel of 25 millimeters, 1 inch, and because I'm not trying to get every point, so I'm doing 5 revolutions. So these 5 revolutions will be 2.5 millimeters. So from every 2.5 millimeters, I'll get a number of points. And this is the frequency. The computer will tell a beep that I'm about to do that. I'm okay to do the measurements because it collected already the data, and as you will see, will tell me it's good to go. Also, all the file I had to zero displacement, very similar like we put measure voltage. This time I call this, instead of time array, I call displacement array, and here I zeroed that. And I do have an index because every time in the for loop I am trying to get 10 measurements, and the index allows me to move from point to point. So at every point I take 10 measurements, and in that case we will be able to see how stable is the measurement system with this potentiometer, and how good, reliable it is. Also, what's the accuracy. And here it is. If initially I go from the displacement, will start at 0, and we will go in steps of 2.5 millimeters all the way to 25, and then we have to go back because we don't have more travel to go. And then every time when I'm doing that, it will be the beep that will tell me, and I also get the measurements. At the end of this, like we did previously, I'm going to save the data in a file. So let's just start it and see how it works. And I do have an error, so it appears that I am running some other stuff in here. Let's see what's the problem with the error. Again, oh, I did not plug the the error is that I forgot to plug the board. Now I have the board plugged in, so let's run it. All right. And I have the signal that I can move 2.5 millimeters. Just did it, and I set, if you look here, I put 15 seconds and I got another point, so I can move. All right. 2.5 millimeters, so got it there. And another 2.5. Got the measurements, as we can see, I get some errors. Not all the 10 points are in the same location. I have some of them right here and others there, so it appears that it's a linear curve, but with some errors, like this one. We'll have to see. So this potentiometers has some low accuracy. Good. So I had two outliers in here, another one there. They're supposed to be in a line, as you can see there. And another outlier there. We see the limitations of this potentiometer. Hopefully yours will not be that bad as mine. And the last one. I set a little bit more points, and you can see the curve right now is starting to lose linearity. And now I have going back 2.5 millimeter. You can see that this zero line, it will align with the horizontal line that's also a zero there. So that's telling me how many microns I am, and if I am straight at 5 millimeters, if both of the zeros are there, then I am 5 millimeters. And now we go back in the curve, which my curve was supposed to be a line. Sometimes we have to watch because we go over 2.5 millimeters and we have to come back. That is the reason I put 15 seconds in the code, just not to be stressed out. I know you can be moving faster than I am here, so I did put 15 seconds here, as you can see, waiting for me. Okay, so I'll go another 2.5 here. And another 2.5. So now I am 7.5 displacement. Alright, now I will go to 5 millimeters displacement from the original. And I hope my sound is good. And another 2.5 going back. And the last point. And now I am supposed that the computer will just move out of, wait 15 seconds, and it will just move out of here and save the data in a file. It just did that. It squeezed 210 points. in that data file. And if I go there, you can see that I call this is a second iteration that I've done today. So if I go here, I will have file number 2, and it's supposed to get the data in 2 columns. Column 1 displacement and column 2 voltage that we measured. So you can see that we went all the way from 0 to 25 millimeters in displacement right there, and then we started to go back toward 0 in steps of 2.5, and you can see I got 10 points every time. This is how I collected, and we will see if we have outliers, as we have seen we do have in some of the points. And then we'll go, like you can see here, we have an outlier, and there some of them. So we'll go over this file and see how we can analyze it and characterize. But first of all, again, we have to learn how do we calibrate the sensor. This is a measurement setup that has to be calibrated. I'm not after voltage, as you guys can see. So on my x-axis would supposed to be voltage, so I get transformation in y-axis in displacement. So this is what I measure, not voltage. I'm supposed to get a measurement device for displacement. And in the next video I'll show how I'll do that. Thank you for watching.